Hello, my name is Uru Purwa. I am from Jadavpur University and the subject is neat chemistry and the topic that I have chosen is chemical bonding. So the first topic of the chemical bonding is Lewis dot structure. Now what is a Lewis dot structure? Lewis dot structures are nothing but the diagram that shows the bonding between the atoms of the molecule as well as the lone pair of electrons that may exist in the molecule. We can draw the H2O molecule using Lewis dot structure. But before that, we want to ensure and understand that what is the basic principle of drawing a Lewis dot structure. The basic principle of Lewis dot structure is nothing but octet rule. The basic principle states that it illustrates the sharing of electron atoms in the covalent bond. In octet rule, it is described that except the helium and the hydrogen, all other elements require 8 electrons to be stable. For nitrogen, we can see that the electronic configuration of the outer shell is 2s2 2p3. So the valence shell has 5 electrons. Now the 3 electrons from each nitrogen atom will form a pair and there will be 2 electrons or 1 lone pair left, and that's how an N2 molecule is being created. Now if we move forward and discuss some of the type of bonding that exist, then we can figure out that there are 5 type of bonding. What are the 5 type of bonding? These types include ionic bonding, covalent bonding, coordinate bonding, hydrogen bonding, and metallic bonding. So first of all, we will understand what is bonding. A chemical bonding can simply be termed as an attractive force which hold various atoms, ions, etc. Now we will discuss what are the properties of different type of chemical bonding. The first type is ionic bonding. In ionic bonding, what happens is that complete electron transfer from one atom to another atom happens. This is happening for the one simple reason that we mentioned above, that is the octet rule. We want to achieve stability. And how to achieve stability? We achieve stability by ensuring that the outermost shell of every atom in a molecule has 8 electrons. While doing this process, we can see that two charged ions of opposite characters, positive ion and negative ion, being created. The positive ions are known as cation and negative ions are known as anions. The example of ionic bonding is very famous, NaCl, sodium chloride, and sodium chloride is created by transferring the one electron in the outermost valence shell of sodium, whose configuration is 281. The one electron will be lost and that lost electron will get transferred to the chlorine and it will become Cl minus and it will attain the state 2,8,8, ensuring that it has 8 electrodes in a valence shell, satisfying the octet rule and satisfying the property of the octet rule, and by doing this an ionic bond is created. Now the next type of bond is covalent bonding. In this kind of bonding, electron pairs between atoms are shared. This bond is the sole link between the atoms of the molecule, and the speciality of this kind of bonding is that This kind of bonding rarely breaks and are quite stable, and these kind of bonds are never broken. The example of covalent bond is oxygen. The O2 molecule has two bonds and two lone pairs each. The next type of bonding is coordinate bonding. In this type of bonding, one lone pair of an atom of a molecule is being transferred to an other atom of a molecule. Sorry, an electron pair is donated from one atom to another. One example of SO2, one example of coordinate bonding is SO2, where sulfur is the donor atom and oxygen is an acceptor atom. We use the the arrow symbol to denote where the donation has been occurred. This type of coordinate bonding is very common in transitional element. Next type of bonding is hydrogen bonding. A hydrogen bond can be defined as an attractive force that binds one molecule of hydrogen atom within electronegative atoms like fluorine, oxygen or nitrogen. Example of hydrogen bond is HF. Metallic bond. This is the collective sharing of a sea of valence electron among a positively charged metal referred as metallic bonding. This kind of bonding is more seen in alkali metals. But there are exceptions found in octet rule which force us to develop a new theory to develop the structure of the molecules and formulate the bonding pattern of these several atoms and molecules. And the limitation of the octet rule can be found in PCl5, where the octet rule is violated because the phosphorus has 10 electrons, and SF6 where sulfur has 12 electrons. Clearly this violates the 8 electron rule strategy or the octet rule. So we moved from octet rule as an outdated approach, and now we move to a more advanced approach known as valence shell electron pair repulsion. When a bond is formed between two atoms, then we can see that the electron that participated in the bond are known as bond pair, and the pair of electrons that do not participate in the bonding are known as lone pair. In NH3 molecule, there are 3 bond pairs and 1 lone pair, and the shape is trigonal bipyramid. Now you must be wondering how we determine the shape also, because it is new, which was not done in octet rule. Similarly, we can see the pattern H2 where there are 2 bond pair of oxygen atom and 2 lone pair of oxygen, and the shape that we can see is determined is bend shape. But how can we determine shapes? How is it possible? Before that, we should discuss something, that the repulsion between the lone pair and lone pair is the highest, and the repulsion between bond pair and bond pair is lowest. The lone pair repulsion causes deformation in the basic structure, which results in a reduced angle between the central atom and the side atoms. So you must have wondered how we derived shapes from just lone pairs and bone pairs. So there is a chart that you can see right now on the screen that if the number of lone pairs is 0 and there are only two atoms, side atoms, that are attached to the central atoms, then we can see the shape that we can get is linear. For three atoms attached, we can get trigonal, planar, or bend shape depending upon the number of lone pairs. Similarly, tetrahedral, trigonal, bipyramidal, and octahedral shapes are being derived. All these shapes are structured using the number of bond pairs and number of lone pairs. So we can say that the summation of lone pair and bond pair is the key property for determining the structure of a molecule, and this number is known as steric number. For example, the BF3 molecule has 3 bond pair and 0 lone pair, which results into the steric number 3, and the resultant shape is trigonal bipyramidal. Here it is. And for SF4, number of bond pairs is 4 and number of lone pair is 1. So it may be confusing for you, so I am simplifying it for you that sulfur has 6 valence shell electrons. Now from that valence shell 6 electrons, 4 are utilized to form one bond each, so 4 bond pair. Now 2 electrons are left. In these 2 electrons, one lone pair is formed, so 4 plus 1 5, the steric number is 5. And if we go to the chart and see what is the structure available for this type of steric number, and we find out that it is seesaw. So this is my small introduction about the chemical bonding chapter. Thank you.